So, I've dealt with a lot since I started app development, but there was one thing that was really hard for me to accept. I had studied a ton about relational databases before I even touched app development, but none of that prepared me for what happened. The rule of the game with databases is normalization. Normalization just means you set up your data tables to reduce duplication and redundancy, which makes total sense. But then I started learning about app development and architectures, and that's when I struggled. The database wants to break everything apart into separate related tables, while the app just wants everything bundled together in one neat package. For example, if you have a player table and an items table, player can have a bunch of items, and in my code, all I really care about is my player object having a list of items inside it. Simple, right? Well, if you have a lot of relationships like this, you suddenly have a choice to make. You either end up with these massive, complicated objects, or you create dozens of different smaller objects for different situations. And before you know it, you've got this insane Venn diagram of objects that makes you wish you'd never started coding in the first place. And I just kept thinking, why can't it be as simple as writing my one clean class for my code, and then I work out how to store it later, without the database deciding how I create my objects? Oh wait, you can already do that. The standard way is to have two classes, one that matches the database table and another model class that you actually use in your app. So why didn't I just do that from the start? Because for one, it relies on the database doing a bunch of queries and joins just to build my object. But that's not the main reason. What I really wanted was more flexibility. Because databases have a strict schema. A schema is just a blueprint that defines what data a table holds in each column. This is great for making sure your data is correct, but it's super rigid. In your code, you can just add a new field to a class anytime you want. But if you want to save that new field to the database, well, you have to do something called a migration. You have to stop and tell the database exactly what changed and how to handle it every single time. Now imagine you have an idea for an app, and your users have great suggestions that require adding a new column to the database. Every time you do this, you need a new migration. I'm just not doing that. It's 2025 and things should be way simpler. I needed something that worked completely offline on any platform and let me be in charge of my objects. I tried the Room library, but I just kept banging my head against the wall. And then I tried Realm, which was good, and it let me work with a single object and handle the storage for me. But the future support and compatibility issues worried me, so back to Room I went. So how did I solve it? I kept modeling my database in the way I was taught before app development. But the two disciplines are different after all. On the inside, I really missed how Realm let me work with one single object while it handled the storage for me. So I abandoned what I thought I knew about relational databases and created a document database. What is a document database? It's part of a group of databases referred to as NoSQL. They don't have strict relations, they just hold a unique ID and a document, like a JSON file, that represents all the data for an object. But wait, Room is built on top of SQLite, which is an SQL database. So how did I do it? Did I reinvent databases? Not really. I just designed my table columns to act like a NoSQL database would. It's actually really simple. Just an ID column and a JSON column, that's it. I'm only half as smart as a rock, so I'm sure others have figured this out before. I just haven't seen anyone talking about it for app development. Here's how it works. You define your table schema. My recommendation is that it has at least an ID and your JSON column. Now that you defined what the database saves, you just need to make sure you create the model class that you want to use in your program. Then you're ready to go. With Room, you would create DAOs, or data access objects, which allow you to actually get the information you need from the database, and this should return the object as you saved it the last time. We did it! Actually, hang on, there's one last very important thing. By doing this, it sounds like we've shot ourselves in the foot and made it impossible to have relationships between tables, right? Wrong. Because this is still an SQL database, we can still define relationships. We just need a little extra thinking on how to manage this new style. This is my approach. For any relationship you absolutely need to maintain, you just add an extra column for it. For example, a column to hold a user ID. These columns are for relationships that are unlikely to change, which means we won't need many migrations going forward. You can also add columns for key information you know you'll want to search for, which gets around a major weakness of many NoSQL databases. Just be aware of one thing. When you save your object, the database has no idea what's inside that JSON. It only knows the columns. Let's say you have a playlist object with a list of songs inside it. If you remove a song from that list in your code and save the playlist object, the database's separate relationship tables won't know that you made that change. Your data will go out of sync and that can end very badly. To fix this, you just have to make sure your code handles everything. When a user does something in the app, like removing a song from a playlist, your code needs to do a couple of things. First, you update the object right there in your code. But then you also have to manually update the database's relationship tables to keep everything in sync. And of course, any other objects that were affected by that change would need to be updated and saved too. It sounds scary, but it's not, I promise. Let's walk through the song playlist example. Imagine our database has two tables, one for song and one for playlist. Most of the time, you'll probably be working with the playlist object, which contains a list of songs. If you want to add a new song to a playlist, it's not hard. You just modify your playlist object in the code, add the new song to its list, and then save that updated playlist back to the database. When you do so, you also add a new row to the song playlist junction table to maintain the relationship between those two objects. So what about when you want to delete a song? That's where we have to get a little bit more involved. If we delete a song from the app, we have to make sure it's also removed from every single playlist that contains it. So here's how we do it. First, we query that junction table and ask, hey, which playlists have this song? Once we have that list, we can go ahead and delete the song. Then we just need to go through each of those playlists we found by their IDs, modify the JSON inside to remove the song, and save them back to the database. So yes, with this method, you'll lose some of the raw power of database queries, and things may be a bit slower because the app has to parse JSON. But in the end, it meets all my needs. It works offline, it works on multiple platforms, and most importantly, it gives me the flexibility to change my objects without a massive headache every single time. It's the closest I'll ever get to a document database using SQLite.